Lesson 11.6 The volume of prisms and cylinders. The learning target is that by the end of today's lesson, we will be able to find volumes of prisms and cylinders. The volume just refers to the number of cubic units in a solid's interior. Now in the first half of the video, a lot of this is actually a review. So I'm going to begin with postulate number 27, which is the volume of a cube postulate. It states that the volume of a cube is the cube of the length of its side. So it's just simply taking S and we cube it, which is actually just length times width times height with 3 S's. Postulate 28 is the volume congruence postulate, and it states that if two polyhedra are congruent, then they have the same volume. Postulate number 29, the volume addition postulate, states that the volume of a solid is the sum of the volumes of all its non-overlapping parts. Theorem 12.6, which is the volume of a prism, states that the volume V of a prism is V equals the base area times H. So big B times H. I could further expand this to length times width times height. Theorem 12.7, volume of a cylinder. The volume V of a cylinder is represented by V equals base area times height, or we could further expand this to pi r squared times H. So again, where B is the area of the base, and H is the height, R is the radius. Now let's practice. Example 1, find the volume of the solid. So for a right triangular prism, I could take the area of the base, I'm going to let this be, and then, so that would be half times base times height, and then multiplying by the height of the prism, which is 2. I'm going to simplify this, so this would be 3 cubic feet. And then for the right cylinder, the area will just be pi r squared times the height of 6. Now, if you leave it in terms of pi, it would just be 150 pi. And if you were to leave it in decimal form, it would be 471.24 cubic meters. And part C, this is a rectangular prism, so we can go ahead and do area equals base area, which is just 11 times 4, and then multiply by height of 5, and then we'd get 220 cubic meters. Example 2. The volume of a right cylinder shown is 1,253 cubic centimeters. Find the value of x, which is just a radius. So we're going to have to work backwards. So the volume is represented by pi r squared h. 1253 is our volume. And then h is 10. So we need to find out what r is. So r squared, after using your calculator, should be about 39.88. And taking the square root of r, you should get about 6.32 centimeters. So this will be your x. And example 3, the volume of the right cylinder is 200 pi. Find the value of x. So this time we're looking for the diameter of the base. So again, 200 pi equals pi r squared, and then our height is 8. We cancel out the pi, and then we get r squared equals to 25, and then r equals to 5. Then x would just be double r, which makes 10. Theorem 12.8, Cavalari's principle states that if two or more solids have the same height and the same cross-sectional area at every level, then they have the same volume. So if you look at the picture to the right here, we have 3 different solids with the same cross-sectional area represented by B here, and they have the same height. And even though they're different kinds of prisms, so the first one would be like perhaps a right rectangular prism, and this will be a right oblique prism, and this will be a right cylinder. As long as they have the same area for its cross sections, so same area, same height, then same volume. Okay, and let's move on to example 4 here. Find the volume of each oblique cylinder. The reason why it's called oblique because it's slanted. So to find the volume of this one, it's actually pretty much just like finding the volume of a right cylinder. So this is what you call a right cylinder, as in meaning it's standing at a right angle. Okay, but this one is just completely slanted at a acute angle. So to find the volume, we still use pi r squared h, and then 5 would be radius, 5 squared, and then we have to use the height that forms a right angle to the base. So it will be 8, and it's given. And then to leave it in terms of pi, it would be 200 pi. And to leave it in decimal form, it would be 628.32 cubic inches. And for this other one here, the height is not given, but we're given a 60-degree angle, which tells us how oblique this cylinder is. But we're given the slant height of 18. And we can use sine of 60 degrees. So opposite, I'm going to let this be h over hypotenuse 18. So my height would be, so if this were 60, this must be 30. So it will be 9 square root of 3. So basically you could just use 30, 60, 90. So this would be 9, and this would be. So now that we have the height, we can find the volume. And the diameter is given as 12, so the radius has to be 6. So pi r squared times 9 square root of 3. The decimal answer will be 1763.01 cubic millimeters. Example 5, find the volume of each solid. So for part A, we need to find the volume of the big cylinder, and then the volume of the smaller cylinder, and then subtract the volume of the cylinder. So large cylinder is represented by pi, and then the radius is 3, so 3 squared is 9, height is 7, so that's 63 pi. And then the smaller cylinder we're given a radius of 1. The 1 times 1 is still 1. And then the height is 7. So that's 7 pi. So large minus small gives you 63 pi minus 7 pi, which is 56 pi. And if you round this, it's about 175.93 cubic millimeters. For part B, we need to add the volume of the cube and half the cylinder. So the volume of the cube would just be 4 cubed, and then half this volume of the cylinder would just be half times pi times r squared. So the radius is 2 since it's 4 here. That's 2 squared is still 4. And the height is also 4. So 4 gives you 64. So 64 plus 8 pi, if you were to leave your answer in terms of pi, then you might be asked to leave your answer as a decimal form, so you have to use a calculator, and that would be 89.13 cubic inches.